It's a pleasure to be here and have a chance to talk to you about this topic. It actually arose, my interest in this topic began early in my career as a graduate student and getting into the field of neuroscience. And later in my life, at the 2018 meeting of the Society of Catholic Scientists in Washington, D.C., I met a scientist who was working in this field, and that helped stimulate my kind of return to neuroscience long after I had retired. And I wrote a big review article down at the bottom, which was called Conscious Intention and Human Action, Review of the Rise and Fall of the Readiness Potential in Libet'S Clock. And so that's kind of the background for this particular presentation. And we're talking about intention. Simple intentional acts, touch your fingers to your thumb, blink your eyes. Here's a picture of a world champion woman pool player. She obviously has an intention. Clint Eastwood in Dirty Harry seems to have an intention in mind. And over on the right, that's me and my wife getting married a long time ago. So that's another form of intention. Intention is part of our legal system. Involuntary manslaughter is killing someone without intention, whereas murder is killing someone with intention. So it's part of the world. The story that led up to Libet's famous study, which I'll get to in a minute, began in 1965, where two German scientists discovered a phenomenon called the readiness potential. And in this particular experiment, Kornhuber and Dickey had a number of subjects. They would sit in a quiet room. They had their head covered with EEG electrodes, plastered, glued onto their scalp. And they asked the subjects to make a simple movement. Flick your hand or your wrist. Do that over and over again, not on a schedule, purely spontaneous. Try not to be regular, but every 5 or 10 or 15 seconds, just make a simple movement. And what they did then, meanwhile, of course, they're recording the EEG, the brainwave activity. And it was maximal at a point they called a vertex. You see the red dot down there, that little circle, the top is the nose and the 2 ears are on the side. So right here on the top of your head, they found this signal that they called the readiness potential. It was only seen after averaging 50 or 100 or 200 movements. In those days, they had to play the tape backwards. They didn't have a computer that could accumulate the signal, so they did this particular experiment. And what they saw was a voltage, a very small voltage of about, in this case, minus 15 microvolts, that began more than a second before the person's voluntary movement took place. So the right side of the graph there is the time 0, that's when the movement takes place. And down at the bottom, we see 0.5, 1, 1.5 seconds before the movement takes place. So you see this slowly rising potential, this voltage, and then closer to the movement, it kind of goes up a little higher. In 1983, a neuroscientist, physiologist at the University of San Francisco decided to take this paradigm, this method of studying movement, spontaneous voluntary movements, but he added a question: when does the person's conscious decision to move actually take place? So he recorded the readiness potential, which you can see in that kind of squiggly blue line going up there. But he also asked the subjects to watch a clock. It wasn't a normal clock, and I'm going to try to get this to work here. So if we can get this. This is what they were watching. So make a movement, but remember where the dot was. Was it at 2 o'clock, at 6 o'clock? Okay, that's the... So he knew when the movement occurred over there at time 0. He saw the readiness potential, which is that blue squiggly line going off up to the right. And he also had the time of the voluntary willing of the movement, which he called the W time, which is those little red dots there. You can see those little red dots. And in each subject, the readiness potential began before the W time, the voluntary willing time. You can see the lines connecting the blue dots to the red dots, and the blue dots are all earlier than the red dot. And when you kind of average those things together, you get a W time on average, which was 0.3 of a second before the movement, and a brain activity, let's call it a B time, that in this case was about 0.75 seconds before the movement. So the conclusion was the brain decides before you decide, okay? So that you think you're having a voluntary movement, but something else is actually going on. Oh, I think I have to hit something here. There, okay, good. There you go. Okay, good. So Libet concludes the brain decides before you decide, and we'll call it all hell breaks loose. So no free will, let me out of jail because my brain made me do it. Consciousness is just a epiphenomenon, an extra meaningless kind of side effect of what's really happening. And this paper, 1983, has had a huge impact for now over 40 years, and is now what I call a key element of popular or folk neuroscience. It's a big, this particular paper has been a big influence. Daniel Wegner, in his book, cited Libet, didn't base his argument necessarily on Libet's work, but he felt it was consistent with his epiphenomenalism. Conscious will is a mere feeling that occurs to a person, but that the brain creates both the thought and the action, leaving to the person to infer that their thought is causing the action. Sam Harris in Free Will said the similar thing. In a recent book, Robert Sapolsky also cited Libet's work in a number of parts of his recent book. If you do a Google search on Libet and free will, you'll get 77,000 hits. If you go to YouTube, the source of all real knowledge in the world, you'll get, I'm a firm believer in that, but believe it or not, 1,258 hits. So it's a big idea. And but some problems have arisen with the Libet study. In recent years, I mentioned at the beginning that at the 2018 meeting of the Society of Catholic Scientists, a scientist named Aaron Serger had questioned the validity of the readiness potential, because it's this averaging of these movements, what they were seeing up here at the top of the head before the movement. But they kind of concluded that the readiness potential may not really be the brain deciding to move, but instead it doesn't really exist because it's an artifact due to averaging random, spontaneous, subthreshold fluctuations in neural activity. So the EEG, the brain waves, there's a lot of slow activity, things happening 2 or 3 times a second, very slow frequencies. And if you average, you can easily get those things generating that slowly rising potential. So this kind of created kind of the first main challenge to Libet's experimental results. And it made it into the Atlantic magazine, another source of great information. A famous argument against free will has been debunked. And so And as I mentioned, Scherger presented this at the 2018 meeting. But even if the readiness potential is not real, this does not really change anything because other studies have found early brain activity by other methods than the readiness potential. So the brain may still be deciding before you decide. And this is an experiment done by a neurosurgeon who was implanted electrodes in the brains of patients awaiting surgery for epilepsy. They wanted to be sure they could identify exactly what functional areas were where so they could avoid them if there was a catastrophic effect of the surgery. So you can see the Libet experiment, as we saw before, only in this experiment, the scientists took this recordings of single cells in the brain, and the people were asked to do the same task. Sit in a quiet room, move your hand every now and then, every 5, 10, or 15 seconds. And they found two types of cells. Some cells increased their activity before the movement took place. That's this big, heavy blue line. Some cells decreased their activity before the movement. So let's look at what this looks like. And they also had the subjects, look at the Libet clock, the dot going around. And this is a movie that they made as part of their paper. That's the cell. That's the clock. That's the movement. So you can see that that cell began its activity. Here's another trial. There it goes. So the movement and the W time. Okay. So it looks like Libet might still be correct, the basic idea. Okay, all right, good, okay. But some of you may recognize Colombo, okay? Is there another way to measure intention, the time of the conscious decision to make the movement? And there is. In 2008, two scientists used what they call tone probes to assess when the conscious decision to make the movement might occur. What a tone probe is so the subjects are sitting in a quiet room, they're making that same little movement, okay? Every 5, 10, or 15 seconds they make a movement. But they weren't watching a clock. Instead, they told them, every now and then you're going to hear a tone. At that moment, assess whether you're thinking about making the movement or not. If you are, cancel the movement. Wait 30 or 40 seconds, start the whole thing over again. If you're not thinking about making the movement, then just go ahead and do whatever you're planning on doing. Okay, so this is the tone probe. And it was developed out of a series of experiments in which people were studying daydreaming or mind wandering. They had people doing a task, reading a book, doing something else, and they'd say, well, let me know whenever you detect yourself, daydreaming or drifting off. And the people would report certain things. And then they decided, well, let's do something else. Let's ask them by probing them with a little tone. Beep, are you daydreaming now? And they found a lot more daydreaming with that than they did with the self-report. So they applied this to the Libet experiment. And what this shows is the movement takes place at time 0. And the green bars here represent the tones that preceded all of these movements that were occurring. And you can see there's kind of a gap of hardly any movements were preceded by tones in the 2 seconds that occurred before the movement. You can see that gap. Well, why would that happen? Because they're giving lots of tones, and these people are doing lots of movements. It's because they're canceling those movements. So the onset of intention is actually closer to 2 seconds before the movement. And this is one subject who, again, did 200 movements. And again, time 0 is the time when the movement occurs. We're going all the way over to 5 seconds before the movement. So they arrange them in order from the earliest to the latest. And all of a sudden here at about minus 1.85 seconds, the number of tones that are associated with movements drastically decreases. So actually the time of conscious intention is more like 2 seconds before the movement instead of 0.3 of a second. So the Libet problem, the brain decides before you decide, goes away because of that. And then so there were another group repeated the same thing, and these red dots are the individual subjects when the onset of intention was using the tone probes. So the first study found that on average was about 1.1 or 2, as early as minus 2.5. A second study by a group in the Netherlands, a woman named Verbachat, again found it even earlier, maybe minus 2.2, as early as minus 3.25. So now we have a very different situation. And actually, they were able to calculate the onset of intention. So here's tones being ignored, 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 and all of a sudden that gap starts to begin and goes down like that. So the Libet's W time, which is over here, is actually just the peak of the conscious intention process, which actually begins about 2 seconds earlier. And so the conclusions. The brain decides before you decide is not true, okay? Intentions begin much earlier. The W time only represents the peak. And in a recent review article in 2023, the simple W measurement must unfortunately be discarded of the onset of the experience of intending to move. So this method, in a way, has been discredited. And so studies using Libet's clock or variations can say nothing about when intention actually begins. There was a recent, there were 2 fMRI studies in 2008 and 2013. They reported changes in the brain up to 10 seconds before the movement, but they have no idea when intention began because they used a variation of the Libet clock. And so folk psychology, which is called belief-desire psychology, that is, your beliefs and desires determine what you're going to do, endures, and we have reason to believe, in the words of a famous American philosopher and cognitive scientist, that my wanting is causally responsible for my reaching, and my itching is causally responsible for my scratching, and my believing is causally responsible for my saying, and that persons can act intentionally for reasons that give the actions meaning and significance. So that's the story about the Libet experiment and why that particular argument against freedom of the will no longer holds anymore. So thank you.